Now, we've all heard about the common rules. Tie your hair back in the lab, wear long sleeves or long pants, and no food in the lab. All of these and other common rules have been ingrained in us since the time we were baby chemists. However, there's an important rule that is not so much talked about, and this rule has to do with boiling. Think about it. When was the last time you were explicitly given safety instructions in lab about boiling? It may seem like a simple task, but if done incorrectly, boiling can lead to some problems. There are a lot of different ways to boil a mixture. Some basic heating devices include a hot plate and a sand bath. Now, let me tell you a story. One seemingly normal day in lab, I was heating a mixture that contained dichloromethane. Dichloromethane has a boiling point of 40 degrees Celsius, which is much lower than water's boiling point of 100 degrees Celsius. However, I failed to notice this low boiling point, and soon my mixture was so hot it began to splatter. My hood was a mess and I lost a lot of product. Now, how can we as lab students prevent splatter that results from overheating or unequal boiling? The obvious answer is to always note the boiling points of the components in your mixture so you can avoid overheating. The next thing we can do is prevent bumping and superheating. Bumping occurs when liquids are heated to boil by forming large bubbles of superheated vapor. Superheating is caused by a temperature gradient in the liquid when lower temperatures are near the surface and higher temperatures are near the heat source. Bumping and superheating can be prevented by boiling stones, boiling sticks, and magnetic stirrers. Stones and sticks trap air in their pores, which aids to create multiple small bubbles instead of a few large ones. The agitation provided by stirring drives vapor bubbles to the surface of the liquids before they grow large enough to cause bumping. While using boiling stones, you should remember to never add them to an already heated liquid. If an experiment calls for the cooling and reheating of a mixture, additional stones should be added before heating once more. Those are the rules to keep boiling from turning into splattering. Apply these rules to common separation and purification techniques like simple distillation, reflux apparatuses, and recrystallization. Keep in mind that azeotropic mixtures do exist, and this will change overall boiling point of your mixture, which can differ from the boiling points of the individual components. There you have it. I hope this prevents you from making the same mistake I did.